Hi, I'm Sita, and I'm presenting on cache basis and utilization. So when we say cache, it's a small, fast memory located closer to the CPU that stores copies of frequently accessed data from the main memory. So this is so understandable. So cache itself is a memory that's installed closer to the CPU, which stores copies of frequently accessed data from the main memory. So now I'm going to talk about cache hit and then this. When we say cache hit, is data is found in the cache. So basically, like during execution, when the processor is able to find the required information, that's simply what cache hit is. And now I'm going to talk about cache miss. So cache miss data must be fetched from the lower level or the main memory, causing delay. So cache miss, the processor is going to seek for the information from the lower level or from the main memory, which causes a lot of delay and takes a lot of time for it to get access to the data. So I'm going to talk about the cache levels. We have the level one, the level two, and then the level three. So level one, closest to the CPU, but very fast and smooth. So the smaller the chip, the faster it is. Level one is the smallest among all, and then it is the fastest. Level two, level two cache, larger than level one, slower but still faster than the main memory. So the level two is larger than level one. And as I already said, the smaller it is, the faster it is. But still, as compared to the main memory, level two is still faster than the main memory. Level three cars, even larger, shared across all ports, slower than the level two. So the level three is larger and then it is the slowest, it's slower than the level two. Acts as the last resort before the main memory access. So simply when there is the need for the processor to get to any level before it gets access to any information, level 3 is basically the last it gets to before it gets access to the information. So I'm going to talk about the cache hierarchy. So the cache hierarchy is organized in the hierarchical structure to balance the speed and then the capacity. So the cache is just organized in steps or in levels, which makes it very easy to get access and then also balances the speed to the capacity. And then data looks up start from level one and proceed downwards if only necessary. So sometimes, as I said, level one is very fast. So when the processor gets to level one and it gets the information it's looking for, there's no need for it to move to level two, level three to gain access to it. So, and then the hierarchy allows the fastest access to the most used data. I'm going to talk about the inclusive and exclusive cache. So when we talk about inclusive, the data present in the higher level is also present in the lower level, which is that when the data is present in level one, it's also present in level two. And then, but wastes a lot space when duplicating the data. So that's the disadvantage of the inclusive because the data is going to be in two levels. It's going to be in level one and level two because it's in both levels. The exclusive, the exclusive, each level contains unique. So the exclusive is just in one level. It's not like if you find it in level one, it means it's not in level two. And then it's more complex to use and it saves a lot of space. Thank you.
Group 1. My name is Nelson Intam. Cache performance. Cache is a type of storage device that stores data temporarily. And when we talk about performance, performance simply refers to how good or bad something is. So let's try to combine the two. Cache performance, it refers to how quickly a CPU can access data that's stored in the cache memory. So don't forget we said earlier on that cache is a storage device that stores data. So anytime you are using your PC or your machine, it is the cache memory that stores whatever thing you are doing, alright? So when you try to retrieve it, the time range it takes for the CPU to access it for you becomes the cache performance. Hit time. It is the time it takes to access data that is located within the cache. Alright. So basically, let me use this example. If I send someone to buy something for me, the time it takes for the person to go and come now becomes the hit time. Alright. So basically, the time it takes for you to be able to get whatever thing you instructed the computer to retrieve for you now becomes the hit time. A lower hit time means faster access to data and improved overall system performance. Don't forget, the faster you get access to your data, the good or the more your system is being improved upon its performance. Basically, if I'm to retrieve a data and then my system is just running slow, it does not help improve my system performance, but rather it helps to reduce my system's performance. Miss penalty. It refers to the additional time needed to retrieve data from the main memory when a cache miss occurs. So basically, when I send someone to go and buy something for me, and then I give the person use 5 minutes, the additional time to which the person uses now becomes the miss penalty, alright? So the additional time it takes for the CPU to retrieve whatever thing you want from the cache memory becomes the miss penalty. Effective access time is equal to hit rate times cache access time plus miss time times lower level access time. I take it again. Effective access time is equal to hit rate times cache access time plus miss time times lower level access time. Simple definitions. Miss rate, the percentage of memory access that results in a cache miss, and then hit rate, the percentage of memory access that results in a cache hit. Factors that affect cache performance: cache size. Larger cache have lower miss rate but higher hit performance. So basically, the higher your cache size, the faster your performance is, because basically if it is high, when the CPU goes to fetch for whatever thing you want, it finds it very fast, and then it is able to move very fast, and then it helps to increase your performance, the performance of your machine. Associativity. Higher associativity reduces conflict misses, but increases hit time due to more complex hardware. So basically, how fast your hardware is able to relate with each other also helps to affect the cache performance, alright? So how it relates to each other to retrieve your information for you also helps. Thank you very much.
My name is Nathaniel Niadi, and this might be Group 1. And I'm presenting on cache mapping techniques. Cache mapping techniques determines how data is stored and retrieved from the code memory. Direct mapping, like we have types of mapping techniques. Which one is direct mapping? It is a simple cache mapping technique where each block of main memory is mapped to a specific location in the cache memory. Now to my second one, he said how direct mapping works. How it works. He said cache organization. The cache memory is divided into blocks or lines, each containing a specific number of words. 2. Mapping function is used to map each block of main memory to a specific location in the cache memory. Tag and index. The tag identifies the block of main memory, and the index identifies the location of the block in the cache memory. Now we have advantages and disadvantages of direct mapping. Now for the advantages, we have simple implementation. It is easy to implement and requires minimum hardware. Fast access. It allows for fast access to the cache data. Now the disadvantage, limited flexibility. It can lead to cache conflict if multiple blocks of main memory map to the same location in the cache memory. Poor cache utilization. People don't utilize it well. It can result in poor cache memory utilization if some lines not used frequently. Now to the second one, fully associative mapping. It is a cache mapping technique where a block of memory can be stored in any location in the cache memory. Now comparison with direct mapping. Is that flexibility? Fully associative mapping offers more flexibility than direct mapping, as a block of main memory can be stored in any location of the cache memory. 2. Cache utilization. Fully associative mapping can result in better cache utilization, as cache memory lines are used.
Today I'll be talking about cache mapping techniques, the part 2. My name is Emmanuel Otuasare. That's my index number. In cache mapping techniques, we have set associative mapping and the least recently used map schemes. Set associative mapping is a hybrid of direct mapped and fully associative cache mapping. Here's how it works. The cache is divided into several sets. Each set contains a number of lines. This is the n-way part. A block from the main memory maps to exactly one set, but within that set, it can go into any of the lines. Advantages and trade-offs of set associative mapping. The advantages: reduces conflict misses compared to direct mapping, offers a balance between speed and flexibility. The trade-offs: slightly more complex than direct mapping, requires stack comparisons across n lines within a set, increasing hardware complexity. Larger associativity like 8-way or more can cause diminishing returns in performance versus cost. This is the second mapping, that is the least recently used replacement scheme. When a new block must be loaded into a full set, that is the all n lines are occupied, a replacement policy decides which existing block to evict. This is a set, right? It's full, right? It's full. We need to evict something. That is where the least recently used replacement scheme comes in. With the least recently used replacement scheme, it keeps track of the usage order of cache lines in each set. The least recently used line is the one replaced. It is a set. It's full, right? The least recently used starts from the back. That is because it is least recently used. So the recently used ones are in front, right? So with this scheme, we evict the least recently used. This is based on the assumption that recently used data is more likely to be used again soon. Implementation: counters or stacks can be used to track usage order. In hardware, simple approximations are used, especially for large n-way caches. We have alternatives for the least recently replacement scheme. We have the FIFO, the first in first out. In accounting, in cost accounting, we say FIFO. It means the first customer to come in is the first to go out. Since he was the first to come, he is the first to go out, right? It replaces the oldest block regardless of usage, simpler to implement than the least recently used, may evict frequently used blocks. And we have the random replacement. It randomly replaces sets. Chooses a random block in a set to replace, low complexity but no intelligent decision making. And we have the pseudo least recently used, that is the PLRU, an approximation of the LRU, the least recently used, useful for higher associativity caches like the 8-way, where full LRU tracking is expensive. Conclusion: set associative mapping is a flexible and widely used cache organization method that reduces conflict while maintaining reasonable speed. The least recently used scheme, though slightly complex, is effective in optimizing cache performance. However, depending on the hardware design and performance needs, alternatives like the FIFO and PLRU, that's the pseudo least recently used, may be used. Thank you.
Okay, my name is Franklin. I'll be talking about cache directories. Cache directories refers to the ability of multiprocessor system cores to share the same memory structures whilst maintaining their separate instruction caches. Also talk about the MESI protocols and the MESIF protocols. We have the modified. The cache line is present only in the current cache and it is dirty, which means it has been modified and differs from the main memory. When we talk about the dirty in the explanation, it means it must be written back to the main memory before shared. We have the exclusive. The cache line is present only in the current cache and it is clean, which means it matches with the main memory. We also have the shared. The cache line may be stored in other caches of the machine and is clean. We also have the void. Indicates that the cache should act as a designator spawner for any request for the given line, which means a single copy of data from which further copies can be made. Also talk about the directory based versus the snooping protocols. Directory based protocol is a central directory which keeps track of which caches have copies of each memory block, reducing the need for all caches to monitor the bus. The snooping protocol. All processes caches are connected to shared bus. Its controllers watches memories transaction to detect if it should update its own cache's copy of data. Effect of its ratio on access time. Mathematical modeling. The average memory access time (the AMAT) refers to the average time given to retrieve data from memory in a memory system. AMAT is equal to hit time plus miss time times the miss penalty, where the hit time is time to access data in the cache, miss time fraction of access that results in a miss penalty, time to fetch data from the next level of the memory. We have a scenario here. Assuming a computer system with level 1 cache, hit time equals 1 nano, miss rate equals 10 nanopercent, which in a fraction form to be 0.10. The level 2 cache, hit time equals 10 nanoseconds, miss rate 40%. In a fraction form will give you 0.40. To also go to the main memory. Access time equals 100. So to solve this, AMAT is equal to level 1 hit time plus level 1 miss rate times level 2 hit time plus level 2 miss rate times memory access time. So with this, you substitute all the values. So AMAT is equal to 1 plus 0.10 times 10 plus 0.40 times the 100. So this one, you first calculate the inner part, which will give you 5, which you add the 5 to the hit time the level 1, so which will give you 6 nanoseconds. That's the answer for the AMAT. Also talk about the types of caches miss. You have the compulsory cache. It occurs when a block is accessed for the first time. It is not yet in the cache. Also have the capacity misses. Happens when the cache cannot contain all the blocks needed during execution. Also have the miss conflict misses. Arise when multiple blocks compete for the same cache location. Thank you.